Alright guys, it's been a while since we've done one of these, so let's see how all of the technology works, and if we have to stop and try again, we will. But for now, let's just go through this sheet of questions. So today we're going to be talking about vector equations, and one of the things we want to ground in here is our previous knowledge. And so what we want to think about when we think about vector equations is linear equations, because they tend to be very similar. So if I had this, the line passing through these 2 points right here, or straight like, we would need a y equals mx plus b equation. And so we would first calculate the slope. We would say that the slope is down 3 over 6, which makes it a half. And then our y-intercept would be this term, right? So y equals -1/2 x plus 3. So y equals 1/2 x plus 3. And you can't stop me, so hopefully we'll be able to handle the blurriness. I can set it as manual maybe. Hopefully that'll help. So if we had a point like -2, 2, we would be able to write an infinite number of equations that could go through that, right? You could have one that went this way, or one that went perpendicular to that. That one doesn't work. One that went perpendicular to that, or one that runs this way. 1, 2, and 3, right? So there's an infinite number of lines that can pass through that point, right? So we want to know, for this point, if I was moving along the trajectory, what would the line be that represented the trajectory and the location of the point? So our goal today is going to be able to write vector equations. The one, and then r equals, I think they call it lambda times t plus maybe some vector. So lambda and b are both going to be vectors, and we'll talk more about that as we continue. So made up a little story here about a little bunny who's hopping along the bunny trail. And Bunny is starting right here. And as time moves along, he travels 2 in the x direction and 2 in the y direction. So this way, 2 and then 2. So after 1 hour, he's right here at 7, 5. And after 2 hours, he'd be here at 9, 7, right? So we can sort of generalize this out to say that if we are starting at a point that we can say that he begins at 5, 3, and then for each unit of time that we count, he moves along the trajectory 2, 2. So he could move forward through time, or theoretically he could move backward through time if we needed him to. So that's what a vector equation is. It's this idea where we have our path is determined by a position plus a direction times t, where t could be represent time, but it could also just represent like moving through a pathway. Okay. So here is a different way of looking at the same scenario. So we could say that the 5 and the 2t represent where Bunny is along the x components. So she began at 5 in terms of the x, and then she's moved 2 every step of time in the x. and correspondingly she started at 3 for our y, and she moved 2 every step for time as well. So we call these parametric equations, and parametric equations are going to highlight the components. Instead of the whole pathway, they just highlight the x components or the y components portion of the pathway. So let's say we just happen to know 2 points. Say we're given OA, OB, so these are our points here and here, and they're on this line. So we want to know what's the vector equation for it. So the first thing we're going to figure out is the direction vector. So what's the direction of this line? And if you look at the line, you can see that it goes either forwards or backwards. Love you too, baby. So we have the direction. You can either move this way along the pathway, or after, okay, thanks. Or you can move this way on the pathway. So it doesn't really matter whether you choose to go from A to B or B to A when you're choosing your direction. It doesn't matter. So we're going to write a vector that represents AB or BA, doesn't matter. So let's say we choose AB. So from A to B, I'm going to go 3 in our x and negative 3 in our y. And then we're going to need a position vector. And so the position could be OA or OB. It doesn't matter, because either one of them gives us the pathway that we're living on. So we're going to say that our vector equation can be represented by, and I'm going to choose OB. Makes no difference. 6, 2 plus 3, negative 3, t. Now, if we wanted to talk about this in terms of the parametric components, you could say the parametric equations are going to be that the x part is 6 plus 3t, and the y part is 2 minus 3t. And now if you did it the other way and you chose OA as your position vector, then the only difference would be that instead of being 6, 2 here, you would have had 3, 5, and so that would have made our parametrics x equals 3 plus 3t, and y equals 5 plus negative 3t. And it doesn't matter if I wrote plus or minus here, or plus negative here, it doesn't make a difference. So those are sort of our general, how can we write about these, how can we talk about these sorts of things. Very commonly, we're going to be asked 3 types of questions: finding a missing component, intersection, and a shorter distance, and we'll look at that in video 2.